Okay, so we're going to talk about discrete and continuous random variables. A random variable takes on numerical values that describe the outcome of some chance process. If I let x be the number of free throws I'm going to make, that random variable x takes on numerical values that describe the outcome. X equals 3. What does that mean? I'm going to make 3 of my free throws. So that outcome of some chance process. Now the chance is, am I going to make it or not? The probability distribution, which we've done before, what do you have to have in a probability distribution? You said it. You have to have sample space. You have to have probability of each thing in that sample space, and all those probabilities must add to 1. Remember doing that? Okay. So the probability distribution of a random variable gives its possible values, that's your sample space, and their probabilities. And there are 2 main types of random variables. There are discrete and there are continuous. A probability model describes the possible outcomes of a chance process and the likelihood that those outcomes will occur. We toss a coin, a fair coin, 3 times. Define x as the number of tails obtained. Make a probability distribution of x. I'm not interested in the sample space, although you may need to look at the sample space in order to figure this problem out. But x is the number of tails. How many times am I tossing it? 3 times. I'm tossing a fair coin 3 times. What are my possible outcomes? What are my possible outcome? Now we're cooking. Say it again. She's got it. And one more. So, right, you did 0, then you did 1, then you did 3, and then we did 2. Okay, that's my, what's that called? That's my sample space. Those are all my possible outcomes. But we have defined x. X is our variable, and that's what we're talking about today. X is our variable, and x is defined as not just all the outcomes, but the number of tails obtained. So what are my values, my possible values of x? You got it. I could have 0 heads, 1 heads, 2 heads, or 3 heads. Tails. Tails obtained, huh? Do you have to have the sample space? No. But you're going to want it. Okay. Now, it says a probability model. If I go back to the top of this screen, a probability model describes the possible outcomes of a chance process and the likelihood that those outcomes will occur. I've defined x as the number of tails. These are the possible number of tails I could obtain. But now I have to have the probability of each one of those outcomes. How many total outcomes do I have? 8. How many of them gave me a 0 tails? So he has a probability of 1/8. How many outcomes gave me 1 tail? How many gave me 2? And how many gave me 3? And guess what all those add to? 8 over 8, which is 1. Okay, so that's your probability distribution of x. Can you do that for me from scratch if I give you a problem? What did we do first? Sample space. Then what did we do second? We did the table. And how do I know, like, how do I know what these numbers are going to be? Common sense. Yeah, but you have to go back and you have to look, what is x? How did we or they define x? And what can that be represented by? And then find the probabilities of each one. Okay, now I want a histogram. What's a histogram? They are bars. Do they touch or not? They do touch. You have an X and a Y axis. Stuff has to get labeled. All right. What are my, what's down here? What are we measuring? Number of tails. Now hold on a second. Do I have to write number of tails, or did we represent or let a variable represent that? So can I just label it X? Because didn't we define X as the number of tails? Okay, what were my possible outcomes for X? What am I measuring? Am I doing how many times, or did we turn that into the probability? What would my highest? Oh, I mean, yes, you could not go above 1. But for my graph, how high do I need to go? 3/8. So I can go 1/8, 2/8, 3/8. So for 0, I'm going to make a bar, and it's going to straddle the 0. And it's going to go up to 1/8 and come down. And then for 1, it's going to go all the way up to 3/8. And for 2, it's going to stay at 3/8. And for 3, it's coming back down to 1/8. Yes, histograms touch. What doesn't touch? A bar graph. A bar graph, and that's categorical data. There are 27 red cars. Because I don't want to go from here to here, because I don't want it to look like, oh, from, well, this doesn't make sense. Let's go from 0 to 1. Like, if I didn't straddle, if I did this, hold on. If I did that, it could look from 0 to 1. Is there any data in between 0 and 1? It's either 0 or it's 1, right? Does that make sense? Guys, that's the definition of discrete. Discrete means it's either this number or it's this number, and there's no decimally crap in between. It's just these particular numbers. What do you notice about this distribution? It is. The board is struggling. It is symmetric. Is it unimodal? Y'all agree? Do y'all agree that it's unimodal? Got some yeses? What's bimodal? Two separate peaks. Yeah, with a valley in between. I don't have that. I guess it could be if it... No. So it is symmetric. Now look at this. What is the probability that we will get, read carefully, at least one tail in the 3 tosses of the coin? Now I want you to take that English and translate it into stats. What do I want? Okay, so all that's English. Translate it into stats. What do I write? Huh? Okay, before you go that though, absolutely that's a way you could go, but back up one step. Like, let's do baby steps. Before that, what do you want? So y'all are going ahead and trying to find it. I just want you to state what the question's asking in stats. Y'all are overthinking. Y'all want this. That's what I want. Probability, so P of, because that's how we represent probability. How can I use this letter X? Because they've already defined it. X is that we're going to get at least one tail, so I need X to be greater than or equal to 1. Are y'all okay? Were y'all overthinking? Yeah, you got to back up. Baby steps. Okay, so to do that, I could do it 2 different ways. I can find the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3. Write that out. You need to see it. It needs to be in your notes. And that's not a bad one. It's only 3 that I need to add together. It doesn't keep going because I cannot have more than 3 tails. But y'all are absolutely right. This can also equal, how else could you write this? Okay, so the probability, put it in terms of X. X equals 0 complement. X equals 0 complement. So how would you write that algebraically? Do y'all agree with that? So you can do, let's see, what's the probability that X equals 1? 3/8. What, X equals 2? 3/8 and X equals 3. And add them together and you get 7/8. Okay, what if we do it this way? 1 minus 1/8, which still gives me 7/8. So the probability that X is greater than or equal to 1 equals 7/8. I want you to get really good at writing it using statistical language. No, these aren't ands and ors. This isn't like probability rules from before. Because these are discrete. They're individual. Let's do some more and you'll see. Do a couple more and then see if you need to ask that. A discrete random variable X takes a fixed set of possible values with gaps. Guys, could you get 1.5 tails? That's going to be huge because I'm going to really kind of try to hammer home the difference between discrete and continuous. So make sure you understand that. For discrete, I can either get 0 tails or 1 tail or 2 tails. But there's no data in between those two. Does that make sense? The probability distribution of a discrete random variable X lists the values and their probabilities. That's what we did here. We list the X values and we list their probabilities using statistical language. The probabilities must satisfy two requirements. Each individual probability must be between 0 and 1, and the sum of their probabilities must equal 1. Does that remind you of a problem from your last test? Or was it the test review? Where it was multiple choice and it was at the bottom of a page. And there were 4 charts, and it said which one is an accurate probability distribution. Was it on your test? The variable x in the coin tossing example is a discrete random variable because, state it again, there are gaps. I can have 0 tails or 1 tails or 2 tails. Okay. Apgar scores. Do y'all know what an Apgar score is? No. Or maybe, I don't know, maybe it's a different test. Every one of you had an Apgar score when you were 2 seconds old. The second you're born, you get an Apgar score. And then you get another Apgar score about 5 minutes later, or maybe 2 minutes later, and then 10 minutes, and then I think it's like an hour. But you get an Apgar score. Okay. In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0, 1, 2 scale to rate a newborn on each of the 5 criteria, because this is something that doctors can do very quickly. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which is going to give you a whole number value from 0 to 10. It is not an average. It is a total. So if I have a 0 to 2 and I've got 5 criteria, if I get a 10, what does that mean? I got a 2 on everything. Okay? What Apgar scores are typical? To find out, researchers recorded the Apgar scores of over 2 million newborn babies in a single year. Imagine that we're going to select one of these newborns at random. Define the random variable x equals Apgar score of a randomly selected baby 1 minute after birth. The table below gives the probability distribution for x. Guys, go look at a 10. What does that mean? There's a 5% chance that a randomly selected baby is going to have an Apgar score of 10. Would you expect that most babies, like before you looked at that, would you expect that most babies would have a 10? I would. I totally would. But that's not the case. Where's the bulk? 8 and 9s. Yep. Show that the probability distribution for x is legit. Tell me why it's legit. Tell you what, but let's write it. So how do you write that? Sum is 1. What are you adding? Are you adding the Apgar scores? Like, you can't just say sum is 1. Sum of all Apgar probabilities equals 1. I mean, I'm all for writing shorthand, but we gotta be careful about what we write. What else has to be true for it to be a legit? They have to add to 1. No. Go back and read. It's in your notes. We just talked about it a couple slides ago. Yes. Each Apgar probability between 0 and 1 Everybody all right? All right, watch me statify this. The probability of each Apgar score is between 0 and 1. Do y'all see it? They would much rather have stats than English. No, that's for this guy. You want to stats this guy up? Do y'all know what the symbol for sum is in math? It's the sigma. The sum of all the probabilities of x equal 1. So that's this guy, and that's that guy. Okay. He says, make a histogram for the probability distribution. Describe what you see. Okay, to avoid having to make another histogram, I've provided one here for you. Let's make sure we're okay with it. Did we label? And I could have labeled this with what? X, because they defined what X was. Then this is the probability of X. I had 0 to 10, and my highest probability was, what, 0.437? So I went up to 0.5. These are tiny, 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 like almost hard to distinguish between the two. And then you can see the big ones. Everybody okay? Everybody can do a histogram. And you'll practice some in your homework. And it says, describe what you see. Skewed left. Everybody agree with that? Absolutely skewed left. Yeah, peak around 9. Unimodal. Sorry, peaked at 9. Maybe a little less than 9 though. Okay, peaked at 9. Because the 8, no, it peaks at 9. I guess I'm thinking more average. It peaks at 9. Doctors decided that Apgar scores of 7 or higher indicate a healthy baby. What is the probability that a randomly selected baby is healthy? You do it. Stats it up. I don't want English. I want stats. Doctors decided that an Apgar score of 7 or higher indicate a healthy baby. What is the probability that a randomly selected baby is healthy? What'd you write? Do you know what you can't do? That I see all the time? And it's so easy to do. Watch. You can't do that. It has to be x equals 7. You can't do the probability of 7. It has to be x equals 7. All right, and then you add and you get what? 0.809? Remember, we go 3 decimal places no matter what. You have to be completely 100% accurate to 3 decimal places. No, I did not get 0.809. I got sorry, 0.908. Everybody okay? Okay. What if I said, so I'm sorry, what is it? There's a 90.8% chance of what? Of a randomly selected baby is healthy. What if I asked for this? Put that in English. So greater than 7 would be 8, 9, and 10. Because we are discrete, there are no values in between 7 and 8. So if we're going to go above 7, that means we jump all the way to 8. Do y'all see that? When we're continuous, that doesn't happen because there's a whole bunch of crap in between a 7 and an 8. Does that make sense? Okay, cool. All right, check. You do this one. Let's see if we can do this one and check it, and then we'll go to lunch. We'll see how fast you guys are. So read. Then you got 1, 2, and 3. Okay, so for number 1, it says, say in words, what is the meaning of the probability that x is greater than or equal to 3? Well, 3 corresponds to a b, right? So make sure you don't just say the probability of somebody whose grade is a or B. It's the probability of a randomly selected student whose grade is an A or a B. How are we on that? Write the event. The students got a grade worse than a C. This is worse than a C, but worse than a C means that you either made a 0 or a 1, right? Right? So you could write it this way, totally fine, or you could write it this way, totally fine. Either way is 100% legit because these are discrete and there's no numbers in between the 2 and the 1. So if I'm chopping off the 2, that pulls me down to 1. And I got a 0.12. Everybody good there? Okay, and then the histogram super fast. You got a 0, a 1, a 2, a 3, and a 4. I'm going to let that be x. This is the probability. I went up to a 0.5. And I don't have them in for, oh yeah, I do. Like that's tiny. Then that one goes to 10%. 2 goes to 20%. 3 goes to 42%. And 4 goes to 26%. Ballpark. How are we? Everybody good? All right, go to lunch. Okay. We have a new word for mean. It is the expected value. The mean, or the expected value of a discrete random variable x, is an average of the possible values of x, but an important change takes into account the fact that not all outcomes are equally likely. I want you to think of an expected outcome like your weighted GPA. Like, what do you get for this class? If you make an A in here, what do you get? You get 5. If this was an honors class, or your honors classes, if you make an A, what do you get? 4.5. If it's a standard class and you make an A, what do you get? You get a 4. Do not sit here and figure out your GPA. So it's all weighted. Well, guys, all these X's have a weight to them. They have a probability. So to find your expected value, you need to take into account the weight. So how would you find your GPA? What would you do? Okay, if you take in, well, let's not do all the same. Let's say 2 honors and 2 APs, and you make A's in all of them. 4.5 plus 4.5 plus 5 plus 5 divided by 4.
0.5 times like the chunk that it has, like it's what 60% you do that times like
If what's worth 60%?
Like wait, what are you talking about GPA?
Mm-hmm.
Well, I don't know. But like I know that in like a weighted class, like a test are at 60%.
We're talking about your grade for the class is an A. So, but you take into account its weight. So, okay, so what if you're talking about within a class? My tests are worth, what are they, 60? My 60-40? So my tests are worth 60%, my quizzes are worth 40%. So you'd add up all your tests and get your test average. Okay, so let's add up all your tests and divide by however many tests we have. Let's say your test average is an 88 and your quiz average is a 91. How would you find your average? How would you find your expected grade? Yeah, 91 times 0.4, so your quiz average times the weight, 0.4, plus your test average, 80, what did I say? 88, times, what's its weight? 0.6, and that would give you your expected value. The mean of a random variable is often referred to as its expected value, E of X. It is the long run average gain or loss. This is a really interesting problem. On an American roulette wheel, there are 38 slots, numbered 1 through 36, plus a 0 and a double 0. Half the slots from 1 to 36 are red, the other half are black, and the zeros are green. Suppose that a player places a simple $1 bet on red. If the ball lands in a red slot, the player gets the original dollar back plus an additional dollar for winning the bet. If the ball lands in a different colored slot, the player loses the dollar. So let's make this a chart. Let's make this a probability model. What could happen to me? What could happen to me with money? Lose or gain what? Everybody agree with that? So I could either lose a dollar, or now am I gaining $2? I'm only gaining $1. Okay, now I need to find their probability. What is the probability? Let's do winning first. What's the probability that I'm going to win? I have an 18 out of 38. What do y'all think? Where's the 18 coming from? Half of 36. So I got 18 red slots out of 38 total slots. What's the probability I'm going to lose? Do y'all see that the odds are in favor of the house? Y'all see that? What is the player's average expected gain? Guys, when you see that word expected, you're thinking that. When you see that word expected, you're thinking E of X. And E of X is the same thing as mu. You need to know that mu and E of X are the same thing. Okay, now, how can I find my average? Think about what we just did with your GPA or with your tests and your quizzes. I can have an outcome of -1, but what's the weight behind that -1? What's the probability that that could happen? Plus, what's the other outcome? 1. What's the weight behind that 1? 18 out of 38. Now grab your calculator and figure that out. What we get? Now, in stats, we go how many decimal places? 3. Why did we go 4? Because I don't like zeros. So we're going 4 decimal places. But this is money. Okay, so does everybody agree that you're going to write this because you're expected to go 3 decimal places? 4 if it starts with a 0. But when you write your sentence, please don't put negative 0.0526 like with a dollar sign on it, because that looks weird. Okay, so it says that we are expected to lose 5 cents every time we play. Guys, am I going to lose 5 cents ever? No, I'm either losing $1 or I'm gaining $1. But what this is saying is based on these odds, in the long run, win some, lose some, on average, I'm going to walk away losing 5 cents. The odds are always in favor of the house. So here's your sentence. If a player plays many times, that is so important. You have to talk about the fact that this is going to happen over and over and over. In repeated sampling, if a player plays many times, they will lose about, guys, this is an average. This is not exact. They will lose about 5 cents. I'm taking the negative off because I have the word what? Lose. Per game, and then here's the kicker, on average. In no way, shape, or form am I ever going to lose a nickel in a game. That's not what this is saying. This is saying on average, this is about where it should even out. You should walk away a loser. Not a drastic loser, but a loser. What are the important parts of this sentence that I'm going to be looking for when I grade your test? Many times. Got to happen many times. On average. The word lose if it's negative. About. These are all really, really key words. Focus on those when you're doing your homework. Apgar scores. What's typical? Compute the mean or the what? Compute the mean or the what? Expected value. Of the random variable x, interpret this value in context. Now, the last problem had 2 values. This problem has 11 values. Do y'all see how long that would be? Like the first one was easy. It was only 2 values. That was easy to write out. Okay, so watch. These are the same Apgar scores from before, yeah? Aren't they really close? Aren't they 1? What? Why not? They're the exact same numbers. Okay. So guys, here's what I want you to write, and then I'm going to show you what I want you to do. You're going to write mu equals E of x. Who is X? That's your Apgar score. Yep. Okay, now here's what you're going to do. You're going to do 0 times 0.001 plus 1 times 0.006. Now here's where the magic happens. Plus plus 10 times 0.053. You're going to give them a couple in the front, a little dot in the middle, and then bring it on home with the last one at the end. Everybody got it? Now go to your calculator. Go to Stat, Edit, type in your Apgar scores into your L1, the probabilities into your L2. Okay, everybody good? Now I'm going to go see if I remember how to do this. Stat calc. Now, I don't want you to look at this like you have two variables. Just because you have something in your L1 and something in your L2, how many variables do you have? One, you have your X. What's in your L2? The probability, the weight. Okay, so I'm doing one variable stat. Do you see how for lists it says L1? Is your frequency list empty? That's where you put a weight. I want to get the weights from where? L2. Do y'all see it right here? Now tell me, what is your expected value? 8.128. That's not expected value squared. That's the sum of all the x's squared. What was it? 128. Is that, do I like inches, miles, feet, pounds? Like, is there a unit of measurement for that? No, there's not. But if there is, you would need to put it. It's kind of, they're just kind of points. Tell me what that means. Make me a sentence. Base it off of the sentence we did for the roulette table. Who wants to make me a sentence? Well, yeah, you're interpreting what the expected value is. Yeah. I mean, make it be about Apgar scores and babies. Who wants to try one? We're not playing the roulette table many times, but what are we doing? Yeah, we're going to choose. We're going to randomly select a baby over and over and over again, many times. So after selecting a random baby many times, What? You can? Eight, comma, on average. Okay, how did we start that? What did we say? After many randomly selected babies, you can't say the baby's Apgar score is 8.128. That's a false statement. But what are we saying? The average Apgar score is about, yep, on average. And there are different versions of that you can write. You need to make it fit the problem. If you say is, it sounds very absolute. It is. It will be 8.128. That's not true. It's still give or take, but that's the ballpark of where it should be. So yeah, that about word or roughly or around, those kinds of those are the CYA words. Notice that the mean Apgar score is not a possible value for the random variable x. If the mean of a random variable has a non-integer value, but you report it as an integer, your answer will not get full credit. What does that mean? I know that Apgar scores are a 0 through 10. This is not a valid Apgar score. But if I take that and say, okay, I'm going to alter my answer then. I'm going to change it to 8. What is this last sentence saying? You can't do that. You will not get credit if you do that. Do not trump your answer. Do not ignore those decimals. If I say, oh, what else could not be a decimal? If I say that on average 2.57 people will do something, can you have 2.57 people? No, that doesn't make sense, but don't you dare round up to 3, and don't round down to 2. Leave it a decimal. An average can be a decimal, okay? All right, standard deviation of a discrete variable. From before, we know that sample variance is defined by the typical standard deviation, the squared deviation from the mean. All right, hold on. Let's review some terminology. Who's that? What's his name? Sigma. Yep, that's sigma. That's baby sigma. This is mama sigma. This is baby sigma. Baby sigma stands for what? It starts with an S. Standard deviation. Standard deviation of the... Which one? What's the other one that means standard deviation? So one of these is population and one of these is sample. This is population. And this is sample. What's population mean? What is the population mean symbol? Nope. It's not a Z. It is. It's mu. That's mean for population. What's mean? Or no, sorry. Yeah, what's mean for a sample? X bar. So this is standard deviation. And this is mean, all for a sample. This is standard deviation, and this is mean, all for a population. Okay, we'll trip down memory lane there. Okay, if this is sigma, that's your standard deviation. I might have mentioned him, but if I did, it was very, very brief. So I'd like to introduce you to variance. This is your standard deviation. This is your variance. Okay? And to get variance, you literally can square your standard deviation. It's totally fine. If I give you variance, how would you get your standard deviation? You would square root it. Okay. So let's go back to this. Let's look. From before, we know that the sample variance, sigma squared, is defined as the typical squared deviation from the mean. What are all those numbers going to be? They're squared. They're all going to be positive. And the standard deviation, S sub x, of a random variable x is a measure of how much the values of the variable typically vary from the mean. Now, what can the standard deviation... no, not going to go there. All right, you see mumbo jumbo, and then you see a formula, correct? Everybody see that? Okay, but go back and look at your calculator. Does it give you a standard deviation? Yes. Right there. Now, it doesn't give you an S sub x because, guys, your calculator doesn't know if this is a sample or a population. So it will always give you the sigma because it doesn't know if you gave it all the information or not. So it's sort of trusting that you're going to give it all to you. And this is just in your notes, it's just going to tell you on your calculator, you can type your value into L1, the probability into L2. You're doing a one variable stats. Just make sure you put your L2 on that frequency list. That's what gives it the weight. Okay. Apgar scores. How variable are they? Compute and interpret the standard deviation of the random variable x. All right. It's already in there. What did you get in your calculator for your standard deviation? Should be sitting right there in your calculator. We just pointed to it. And I'm just going to go 3 decimal places. Okay, so we're going 3 decimal places. Now, tell me what that means. We got babies. We got scores that tell me how healthy they are. This is a standard deviation. Tell me what that means. Don't write a sentence because you're going to mess it up. Let's just talk. Standard deviation. Typical difference from the expected value? Not predict. I'm not predicting anything. What the expected value is, so what the average is. Okay, so can you put the number in there? What's the one piece he left out? No. No. I'm not predicting anything. It is in the family of residuals. Absolutely. But a distant cousin. But it should make you think of residuals. But I'm not predicting anything. It's not observed minus predicted. What's the one teeny thing that he forgot? No, you don't have to have the many, many times on this one. But what are you doing many, many times? You are randomly selecting a baby. Okay. A. Randomly selected babies. Apgar score will typically differ, I'm going to use, from the mean, but here you could also say the expected value if you wanted to, by about, that's the cover your butt, 1.4. I don't like not having any units on these, so I'm just going to say 1.4 units. If it was feet or inches or pounds or days or people. So can you see me in the future? Can y'all listen and write at the same time? Can y'all see me in the future give you a problem, ask you to find the expected value and the standard deviation and interpret what both of them mean? And I want two very specific sentences for those. Practice on your homework. Everybody cool? Guys, is finding this number difficult? That's not what stats is about. It's not about being able to find that number. Maybe that's 2% of what it is. It's what does that mean? That's the big picture. Okay, here we go. We have a large auto dealership. Keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. Compute the mean and the standard deviation and interpret both meanings. Have y'all ever been to buy a car with your parents? Have you ever been to a car dealership? When you walk up, this is what I've noticed. It's very awkward because it's like I'm going to walk up and there are four of you just standing there. And it's like they elbow each other out of the way to see who's going to get me. Because what am I to them? I'm commission. That's what I am. Because if they sell me a car, guess what they get? They get a percentage of that. And the guys who don't come to me, who don't help me buy a car, they don't get any of that. They get a very, very small hourly wage for standing there. So there's massive motivation to get, and I'm sure they've established some sort of like rotation. Well, I got the last one, you can get this one. Because otherwise they really would be elbowing each other out of the way. So we have a large auto dealership. And they keep track of sales. Now this is on a Friday. If I'm working Friday, do I want to work in the third hour of Friday? What is this 0.1? What is this 10%? 10% of the cars sold get sold during the third hour of Friday. Oh, that's right. This is cars sold, not hours. You're right. This is 3 cars. So what is the probability? So this is a really small probability that there are 3 cars sold. So do you want to be that third guy in the first hour? No, you don't. I want to be the first guy because there's a 40% chance he's going to get a car sold in that first hour. Y'all see what I'm talking about? There's a 30% chance that none of us are going to sell a car. There's a 40% chance that guy number 1 is going to sell a car. then while he's selling that car, there's a 20% chance that guy number 2 is going to sell a car. Car number 2. Does that make sense? Compute the mean and the standard deviation and interpret both meanings. Good. Find them and write me beautiful, gorgeous AP level sentences. And stats it up. Give me symbols and stuff. Okay, let's take a look at what I've got. All right, I've got a mean of 1.1. Agree? And you could write mu sub x, or you could write what? E of x. Yep. I've got a standard deviation, so sigma sub x of 0.943. Again, no just floating numbers. Okay, here's my sentences. Here are my sentences. If many Fridays are selected, check, done that. The average number of cars sold during the first hour of business will be 1.1 cars on average. I could probably throw in the word about in there. You have to have many Fridays. The average number of cars sold during the first hour of business will be about 1.1 cars on average. The number of cars sold during the first hour of the selected Fridays will typically differ from the mean by 0.943 cars. The number of cars sold during the first hour of the selected Fridays will typically differ from the mean, that's what a standard deviation is, by 0.943 cars. Questions? Everybody okay? Because I will nitpick your sentences to death. They have to have all the components that they need to have. Everybody okay? Okay. All right, that's it for discrete. Apgar scores, cars. Now let's talk continuous. A continuous random variable x takes all values in an interval of numbers. The probability of any event, sorry, missed the T there, is the area under the density curve and above the values of x that make up the event. What does this remind you of? A normal distribution. You should be thinking normal CDF. It's the values under the curve. The probability distribution for a continuous random variable assigns probabilities to intervals of outcomes rather than to individual outcomes. Guys, that's a great sentence. I need you tuned in. I feel like some of you are just kind of sitting here. Assigns probabilities to intervals of outcomes versus individual outcomes. If they're individual outcomes, what am I? What kind of variable am I? Yeah, it's written on the board. Have y'all been here like for the last hour? If it has individual outcomes, what am I? I am discrete. If it's continuous, it's a whole interval because there are all these values in between those numbers. Suppose we want to choose a number at random between 0 and 1, allowing any number. between 0 and 1 as the outcome. The sample space of this chance process is an entire interval of numbers. Can you sit here and write every single individual number that's in your sample space? No, literally these decimals go on forever. So I write my sample space as all the numbers between 0 and 1. Call the outcome of the random variables y. We're going to switch it up. Instead of using x, we're going to use y. How can we find the probability of the events? Okay, now look. What is this saying? That's stats. Give that to me in English. What's y? Y is an event. What is y? Guys, come on. Come on. What's y? If you're answering, I can't hear you. Any random number? What's your sample space, guys? Y is any number between 0 and 1. Call the outcome of the random numbers y for short. Y is any number between 0 and 1. Those are all my outcomes. I want the probability that any random number between 0 and 1, I want to find the probability that those numbers are going to be between a 0.3 and a 0.7. That's what that says in stats. However, like this sample space is infinite, even in between 0.3 and 0.7. Those decimals can go literally to infinity. All numbers have an equal probability of occurring. So guys, this is not a normal distribution. This is not a curve. In a curve, in the middle of the curve, they have a higher probability of happening than they do in the tails. That's not the case here. Every number has an equal opportunity of happening. But we can't assign probabilities to each individual value of y and then add them all up, because how long would you be here? Literally for infinity. Like, you'd never finish. Because there are infinite many possibilities. We're going to use a different way of assigning probabilities as an area under a density curve. But remember, the area under a density curve has to equal what? Because the total probabilities have to equal 1. If it's a normal distribution, it looks like that. But this is not a normal distribution because every number has an equal chance of happening. What does the density curve look like for the probability of selecting a number between 0 and 1? Straight across. They all have an equal chance. Now, here's my question. What's that value right there? Use some math. Why? It is a 1, but that's not the reason why.
It's not guaranteed that we're going to get 0. Because you can get something else.
What did y'all say the area under the curve had to be? Think of this as a rectangle. Length times width. Y'all see it? If the area under here is a 1, and I know this is 1, then what does this have to be for the area to be 1? Now, I want the probability between what and what? No. Probability 0.3 and 0.7. So look, I come in here and I go 0.3 to 0.7. And just like under the normal curve, we block it off and shade it in. Now, we answered the question, what does a density curve look like for this? It looks like that. All right, look at this last part. What is the probability? So I want the answer for this.
You know how to find, so you would do 0.7 minus 0.3.
Which is? Oh my gosh, 7 minus 3. 7 minus 3.
Yeah.
Yes. So 0.4 times. No, you're not. You did 0.7 minus 0.43. You got 21. It's the area of that rectangle. Well, the area is length times width, so 0.4 times 1. So there is a what? There's a 40% chance that you'll select that you'll randomly select a number between 0.3 and 0.7.
If you could cut and if you off at a certain number, choices.
Right. Okay, now here's something that's going to blow your mind. What's the difference? It's so slim that we don't even recognize it. If this is continuous, if I take the equal to off of this, how close to 0.3 can I get? 0.3 forever 1. Like that's how close I can get. So if you're talking about the difference between that number and a 0.3, it's so close, it's non-existent. So guys, there is no difference. Have you ever, when you go to cut a piece of cake and you say, I'm going to eat a fourth of this. And you come in here and you say, okay, here's a fourth. Well, that's a fourth. Here's a fourth. Are you going to cut on that line? Or are you going to cut just over that line? Do y'all see what I mean? Like, there's no difference. Either way, I'm getting 25% of this cake. It's not about it's not about if you slice it on the line or just on the other side of that line, because it's cake. There's infinite number of cake in between where you can slice it and where you can slice it right beside it. It's non-existent. There is no difference. Okay, now, sidebar. Okay, I need your brains on, okay? Y'all ready? Go back to discrete. Is there a difference in that for discrete? Yes. This jumps down to what? 1 and below. This is 2 and below. Big gap right there. If I am continuous, is there a difference? No. And that's what I need your brains to wrap around. Everybody okay? Okay, last one. Young women's heights. Would this be discrete or continuous? The heights of young women closely follow the normal distribution. Normal distribution. with a mean of 64 inches and standard deviation of 2.7 inches. This is a distribution for a large set of data. Now choose one woman at random. Call her height Y. If we repeat the random choice very many times, the distribution of values of Y is the same as the normal distribution that describes the heights of all young women. Find the probability that the chosen woman is between 68 and 70 inches tall. Draw me a beautiful normal distribution. What is your mean? 64 inches. What are we interested in? So I slice my distribution and I shade it in just like I did on the rectangle. This just happens to be a normal curve, not a block. So I am finding the probability of what? Write in stats what I'm trying to find. Less than. Which was? Do you have to have the equal to? It said between 68 and 70, so does that include the 68? Does it not? Technically, it doesn't matter. Now, how do I do this? No. I'm telling you where I want you to cut it. So you're going to normal CDF from uh-huh. 68 to 70, and what is your mean? And what is your standard deviation? Go type. Go see if you remember. Remember, we go 3 decimal places. You have to be correct to 3 decimal places. I'm not a big fan of zeros. I got 0.0561. So what would your sentence be? There is a 5.61% chance, then go back and state your problem. That a, whoa, back up. That a randomly selected woman, young woman, is between 68 and 70 inches tall? No, because this is not her average. This is the percent chance that that's going to happen. So there's about a 5.61% chance that a randomly selected young woman has a height between 68 and 70 inches tall. Hold on 1 second. Look at this little nugget of information. When showing your work on an FRQ, you must include more than a calculator command. Writing normal CDF and all your information will not earn you full credit. At a minimum, you must indicate which each of these calculator inputs represent. Better yet, sketch and label a normal curve. When I taught you the normal CDF, didn't I say whenever you write normal CDF, you should have a curve? Okay, so now what they're saying is the 68 and the 70 I can see from here. Who is this? So mu equals 64 what? And sigma equals 2.7 inches. Label where your numbers are coming from. You can, but that's kind of showing that you're scared that you don't know what the symbols are. We're going to use these so much between now and May, you're not, I promise. So don't fight it. Go ahead and start getting in the habit of it. Okay, are we good? Discrete and continuous.